So the first problem says, Jessica has 2 1/3 pounds of candy. That's how much candy Jessica has. She gives 1/4 of the candy to Jenny. How much candy does Jenny actually get? Now, if we read the problem, you'll see it says right here, she gives 1/4 of the candy to Jenny. And we've mentioned over and over that in word problems, typically the word of usually means multiplication. And that's what it means here. We know that Jessica has 2 1/3 pounds of candy, and she gives away a certain amount of it to her friend, 1/4 of that amount. So we need to multiply these fractions together. Effectively, we're chopping down that 2 1/3 pound bag and taking 1/4 of it away. So the way to do it is you write it down and you say, well, 2 1/3, that's how many pounds of candy we have. And we're going to chop that down by 1/4, and so we're multiplying that together. Now, when you write it like this, you realize what you have is a mixed number times a fraction. And in order to do that, we have learned that we want to convert the mixed numbers. So here we have 3 times 2 is 6, plus 1 is 7. So that'll be 7/3, because we always write it over the denominator. And then we're going to multiply by 1/4. Multiply by 1/4. So what we have right there is two fractions that we know how to multiply. Any two fractions, we just multiply the numerators and multiply the denominator. So 7 times 1 is 7. 3 times 4 is 12. So we have 7/12 is the answer. We try to reduce it, and we can't reduce this anymore, so this is it. So 7/12 of what? Of a pound. All right, now if you think about it, 6/12, 6 over 12, would be 1/2. So this is just a little bit more than half of a pound. So if Jenny actually has 2 1/3 pounds of candy and decides to give 1/4 of it away, multiplying it out, she's actually given 7/12 of a pound, which is just a little bit more than half a pound, because half a pound will be 6 out of 12, 6/12. All right. So again, we read the problem, we try to understand and see what it's asking us to do, and then carry it out. So the next problem says, Martin grows a plant that is 2 1/5 inches tall. James is growing a plant 2.5 times taller than Martin. How tall is James's plant? So here it's a little bit different. We have a different keyword to look for. We know that Martin grows a plant 2 1/5 inches tall. James is growing a plant 2.5 times taller. The word 2.5 times implies multiplication. When you think about it, times tables, multiplication tables. So if something is 2 times larger, or 3 times larger, or 5 times larger, you're multiplying. Here it's 2.5 times larger. So in order to pull that off, basically we write down what we know. We know that Martin's plant is 2 1/5 inches tall, and we know that James is growing something that's 2.5 times taller. So this is what the original plant is. We're multiplying it by 2.5 times because the other guy's building or growing a plant that's much, much taller. All right, and so we have now two mixed numbers multiplying together. That's okay, we know how to handle that. We convert each of them to improper. 5 times 2 is 10, plus 1 is 11 over 5, and then we're multiplying by this guy, which 2 times 2 is 4, plus 1 is 5, and we write it over 2 here. We write this fraction over 5 because that's the denominator here. We write this fraction over 2 because that is the denominator there. Now that we have two regular fractions, well, they're improper, but we know how to multiply those together. 11 times 5 is 55. 5 times 2 is 10. So this is the final answer, but you know, there's a few things we can do here. First of all, notice this is an improper fraction. So we could convert right now to improper if we wanted to, or to a mixed number if we wanted to. Or we also notice that this is divisible by 5, and this is also divisible by 5. We can divide top and bottom by 5 and simplify it. We're still going to have an improper fraction at the end of the day. So no matter what you do, which path you take, you're going to get to the same correct answer. So it's really up to you. What do you prefer to do? In this case, let's go ahead and just convert it to a mixed number right away. So 55 divided by 10, how many times will this go? Well, it will only go 5 times because 10 times 5 is 50, right? Can't do 6 times, that would be 60. So it goes 5 times for 50. The difference between 55 and 50 is only 5, so the remainder is 5, and you write it over the number 10. So the mixed number is 5 5/10. But now that you have it written there, you can see even more clearly that I can divide this fraction by 5 and divide this fraction by 5. to simplify it. And so I would get 5. 5 divided by 5 is 1. 10 divided by 5 is 2. So the answer is 5.5. And 5.5 what? 5.5 inches tall. What it's basically saying is if Martin is growing a plant 2 1/5 inches tall, which is just a little bit more than 2 inches, and he's growing something 2.5 times as tall as this guy's plant, it's going to be 5.5 inches tall, and that makes sense based on the numbers. Now, what we chose to do here was convert to mixed number and then simplify the fractional part, getting this. Instead, we could have chosen to simply simplify this. We could have divided top and bottom by 5, for instance. Then we would have still had an improper fraction. We would have converted to mixed number, and we would still get exactly the same answer. So no matter which way you go down the road of simplifying your answer, you should get the same answer no matter what you choose to do, as long as you're doing the right steps. And that's why we're doing a lot of practice here, to give you that confidence. So the next problem says, a playroom measures 2.5 meters long and 3.5 meters wide. What is the area of the playroom? Now, we haven't talked about surface area much, but the bottom line is we have a playroom here, all right? And so the playroom, we could just draw a little picture, is a rectangular in shape. And the problem tells us the playroom measures 2.5 meters wide. So this is 2.5 meters wide, and it's 3.5, actually it's, I've got it going the wrong way. It's 2.5 meters long and 3.5 meters wide. So what we have, this guy, this is the playroom right here, and the width of it is 3.5 meters wide. And it's 2.5 meters, we can call this long. So we'll call this 2.5 meters long. So this dimension, one side of the rectangle is 2.5, and the other side of the rectangle is 3.5. And so basically, when you have a rectangular shape like this, and if you know the different sides and the different lengths of the two sides, to find the area, what you're trying to do is find out how much total surface is covered here. Like if you were going to lay carpet, you would need to know how much carpet to put all over the entire floor. The way you figure that out is to multiply the length, or multiply the width by the length, multiply the two sides of the rectangle together, and that tells you how much area that you have. So the area, in this case, is going to be the multiplication of 3.5 meters times 2.5 meters. And that would tell you how much you're covering this entire floor here. We're going to come back and talk about area a whole lot more later when we get down into talking about geometry and area. But for now, we're just trying to multiply these numbers because it's good practice. So how do we do this? We convert. 2 times 3 is 6, plus 1 is 7. We write it over 2. 2 times 2 is 4, plus 1 is 5, and we also write it over 2. So now we have two fractions, and we can multiply them. 7 times 5 on the top is 35. 2 times 2 is 4, and we can write that on the bottom. So we see we have an improper fraction. So then we simplify by saying, how many times will 4 go into 35? Well, 7 times 4 is 28. 8 times 4 is 32. 9 times 4 is 36. That's too many times, so it can't be 9 times. 8 times 4 is 32. So it can actually go 8 full times in here. 32, the difference between 35 and 32 is 3, and we write it over the denominator. So 8 3/4. That is the answer. Now, if this is meters going this way, and this is meters going this way, because you're multiplying them, the answer you get is something we call square meters. All right, so what this represents is if we had to lay carpet down, if we got a pencil out here and we drew how many square meters we have in this whole thing here, if this is a meter on each side, each little square inside of here is called a square meter. There's 8 3/4 of these square meters running around the whole surface. And that is how you order things like carpet. You specify how many square meters you need to buy. Or if you're even purchasing paint, you're trying to paint a wall. Well, the can of paint is going to tell you how many square meters or how many square feet that surface will be covered by the paint. So that's how you do that. If you know the length and the width, you multiply those numbers to get how many square meters or how many square feet, in this case, which we're talking about meters, so it's square meters, that it's going to require to cover that surface. Again, we'll talk a lot more about surface area and square meters and square feet much later in the course, but here's a great practical example.